We're continuing on section 15.6, change of variables. We want to share a little useful fact about Jacobians with you. So let's say we're trying a transformation g of u and v equal to x and y. Then the inverse of that is f of x and y equal to u and v. Basically, if g takes u and v to x and y, f takes x and y to u and v. And then the Jacobian of f is going to be the reciprocal of Jacobian of g. If you look at the notation, see output of f is going to be u and v, input of f is x and y. So the notation is like that, and the notation for g is it's partial of x and y, which is the output, over partial of u and v, which is the input. And so in the notation was there was an intention in there, so you can see that they're reciprocal of each other. As in a lot of calculus, the notation is said that it gives you ideas about how they work, not how they are, but how they work. And so that's about the Jacobians. And then the other thing that I want to mention is that using this for any old transformation may not do any good, because even though they are inverse of each other, one is with respect to one variable, the other one is with respect to another variable. So it usually doesn't do a whole lot of good. But it does a lot of good with linear transformations, because with linear transformations, you always have the Jacobian is a constant, and knowing that the Jacobian of the inverse, which is a constant, is the reciprocal of the Jacobian of the transformation, helps a lot. So that's the basic of the story. So in general, if the Jacobian is non-constant, is not very helpful. With linear transformation, Jacobian constant is very helpful. Example. Evaluate the integral from 0 to 1, and integral from 0 to 1 minus x of square root of x plus y times y minus 2x to power 2 dy dx. This is another case that you feel like, oh, if I want to make this a little easier, I would like to assume that x plus y is u and y minus 2x is v. And would that make my life a little easier? For one thing, the integrand becomes u to power 1/2 and v to power 2. Does that make but then look at the r over here. Looks like it goes from x goes from 0 to 1, and then y runs from 0 to 1 minus x, which is right there. And so this is the region that we have right now. This side is x plus y equal to 1, or y equal to 1 minus x is that, and this side is x equal to 0, y equal to 0. This one is x equal to 0. If I want to find, this is r again, if I want to find the pre-image of it, and pre-image it over here, over u and v, again, what we're setting up, u equal to x plus y, v equal to y minus 2x, is a linear transformation. G of x and y equal to x plus y and y. I'm sorry, the other way around. What we're saying is G inverse of x and y is equal to x plus y and y minus 2x, which this part is u, this part is v. And so this is a linear transformation. If the inverse is a linear transformation, the transformation itself is a linear transformation. So I can think about just finding these 3 points, the preimage of these 3 points, which here is 1 and 0. Plug it into here, I get 1 and negative 2. So 1 and 0, and then 0 and 1, and I'm plugging it into here, and I get G inverse of 1 and 0 is going to be 1 and negative 2. 1 and negative 2 out here. And then the next thing that I want to find is the G inverse of 0 and 1. If I again plug in G inverse of 0 and 1, plug it in here, 0 for x, 1 for y, and I get 1 and 1. I get 1 and 1. And so that is out here somewhere. And then if I plug in 0, 0 in here, I get 0, 0. So this is the region that I'm seeing. And so the region is not too bad. It can be y simple, and we can integrate from there. Now, how do I find the Jacobian in here? When I'm trying to find the Jacobian, normally I have G. In here I have G inverse. Do I need to find the reciprocal? Do I need to find the G inverse, to find inverse of G inverse to find G or not? Well, at this point I have all the information that I need, and all I need to do is basically, instead of using the Jacobian of G, I'm going to use Jacobian of G inverse, and I basically find the reciprocal of that. So let's figure out Jacobian of G inverse of x and y, which is going to be the Jacobian partial of u respect to x, partial of u respect to y, partial of v with respect to x, partial of v with respect to y. And that is here, this is u with respect to x is 1, u with respect to y is 1, here u with respect to x is negative 2, u with respect to y is 1. So again, determinant is 1 times 1 minus 1 times negative 1, which is going to be 3. So I found Jacobian of G inverse. So Jacobian of G is going to be 1/3, basically. Jacobian of G is equal to 1/3. I have all the information. Before moving on to the next page, I want to make sure that I know what these are. This one is u equal to 1. This one is u equal to v. This one is u equal to v equal to negative 2u. And so now that I have all this information, I can set up my integral, and my integral will look like this. So we said it's v simple, and it goes from negative 2u to u, and then u runs from 0 to 1, and then the integrand we found was this, and this is for the Jacobian. This is this is actually the rescaling factor, and that's the integrand. And now we're ready to take the integral, and it's a lot easier than we started. And it can be separated and integrated separately, and you get 2/9 as your answer. Let's do one more example, and in this time, the change of variable is going to make the um, region a lot simpler. We've done a few that we made the integrand a little bit simpler. So in here, we're looking at a region that is bounded by xy equal to 1, xy equal to 4, y equal to x, y equal to 2x, and integrand is fairly easy to do, and then we're asked to find this integral and over this region basically. And so what I notice is that there is the x and y between 1 and -1, and y over x between 0 and 2. And it seems like this could work for me in this situation. I also notice that if I multiply let's say xy to power 2 times y over x, then I get that integrand up there. So it looks like a good option for change of variables. So let's see, if I use this as u and use this as v, would I get the right region basically. So before I always looked at the integrand and I chose something. In this case, I'm looking at the region and I'm choosing u and v. And so in here, again, I will have the inverse, that is g inverse of x and y is going to be u and v, which is, I chose u to be xy and v to be y over x. And now can I find what g is? Yes, if you basically if you want to solve for x and y over here, this is u, this is v. So if I multiply u times v, what I get is going to be xy times y over x, which is y squared. So y is equal to, and I know we're on the positive side, square root of uv. Then I can use this to actually solve for x. X times y is equal to it's equal to u, and I know y is square root of uv, so I eliminate and I figure out that x is going to be equal to u divided by square root of uv, which is x is equal to u to power 1/2 v to power -1/2. And so that's my transformation itself. So according to the choice of, we chose u to be xy and v to be y over x, and therefore let's see, u to be xy, and xy is supposed to be between xy is supposed to be between 1 and 4, and so that makes u between 1 and 4, and we said v is equal to y over x, and v in here is let's see, that in here, for example, y over x is equal to 2, this one y over x is equal to 1, so v is between 1 and 2. So that's my region, and it's rectangular. And so we figured out g as well, and as well as g inverse. Now I would like to find the Jacobian. This is Jacobian of g, because I solved for g. Again, you see, so I'm basically finding x with respect to u, and I'm finding x with respect to v, and then y with respect to u, y with respect to v, and I get 1 over 2v. So the integral that we saw in the beginning converts to these bounds, and then by then the other thing that we have over there is that the integrand that we have to resolve, and we found the Jacobian, and v is always positive, therefore Jacobian is positive. The order of u and v follow from what they're supposed to be. Now integrand in the original was x y to the power 3. If I use what I have here, that's x times y to power 3 half, I will end up with u squared divided by u squared v. And then divided by 2v, I get u squared divided by 2. And integration there gives me 21 divided by 2. I click here question 15.6, part D. I click here D. Let R be the planar region defined by this R equal to 0.6 and y, such that 2 is less than equal to x minus y, less than equal to 5, and 1 is less than equal to x plus y, less than equal to 3. Which of the following is equal to double integral over r of f of x and y over the region R? I suggest pausing the video for a minute, thinking about this problem, and coming back. So I hope you pause the video. Let's start working on this. And so it seems like this question is asking us to make the region a little simpler. And over here, if I want to make the region simpler, each one of these, when I said x minus y equal to 2 and x minus y equal to 5, the boundaries are lines, and here also 2 lines. And it seems like I want to make them, so the lines are not vertical or horizontal. It seems like I want to make the region rectangular. And so I'm going to go with this one as u. That the question could have done it differently, but let's see if it's, they could have switched v and u. But let's say we're going about doing that. If I go like that, u has to be between 2 and 5. Let's see if there is any of these options that u is not between 2 and 5. So this one matches this, and also matches that, and also matches this. So these three u and v are set as we set them up. What is remaining is that I have to replace x as a function of u and v and y as a function of u and v. So how do I do that? Remember, so what we are having here is G inverse. And G inverse, if I plug in x and y, it gives me u and v. And so in here, so this is u, this is v. Let's solve for x and y, so I can figure out how x and y are functions of u and v. So here, u equal to x minus y, v equal to x plus y. Add them together, you get x is equal, 2x is equal to u plus v. So 1x is u plus v divided by 2. Then subtract v minus u, and that's 2y divided by 2 to get y. Does any of these three match that? Let's see. This one doesn't, that one doesn't, but this one does. Okay, and so the answer is going to be, and then notice also that over here the inside matches that, but the bounds don't match. So that is everything is matching. The only thing that you really want to try is to take the Jacobian and make sure the Jacobian is 1/2, because there's a 1/2 in here. And I try to do the Jacobian, and I can do either one of these. I can do x with respect to u, which is 1/2, x with respect to v, which is again 1/2, and y with respect to u, which is negative 1/2, y with respect to v, which is 1/2, and then it's 1/2 times 1/2 minus 1/2 times negative 1/2, and that's again is 1/2. So that was correct, and that is the answer.